Good morning. Myself, Prabha Anjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is pipelines from the unit 3 of sequential logic circuit in VLSI design. Let I discuss. Yeah. Before that, we should know about what is meant by combinational logic, what is meant by sequential logic. The output of the circuit depends on current input, then the circuit is called as combination logic circuit. The output depends on current and previous inputs, then the circuit is called as sequential logic circuits. Okay. uh, in VLSI design, pipelines in sequential circuits are a critical technique used to improve performance by increasing the throughput of a system. Pipeline architecture is widely used in digital systems, especially in processor, to allow for multiple instruction or data elements to be processed in parallel, leading to high efficiency. Okay. Here you can see the critical path in any design is the longest path between any two internal latches, flip-flops, any input pad and an internal latches, an internal latch and an output pad, an input pad and an output pad. Here you can see pipelining. Yeah, pipelining comes from the idea of a water pipe. Continuous sending water without waiting the water in the pipe to be out, used to reduce the critical path design. It is called pipelining. And self-timed pipeline path. Let me discuss the self-timed pipeline path. Here we have to discuss some points, that is asynchronous operation, handshake protocol, variable stage latency, data flow control, and low power consumption. Before that, we should know about what is self time pipeline data path. It is a type of asynchronous pipeline where the flow of data through the pipeline stages is controlled without relying on a global clock signal. Instead, it uses local handshaking protocol or control signals to manage the transfer of data between stages. This is in contrast to traditional clocked pipeline, which rely on a central clock signal to synchronize data movement between stages. In self-time pipeline, each stage operates independently and only proceed when it receives an acknowledgement from the next stage that it is ready to accept a new data. This leads to more efficient data processing in systems where data arrival are irregular, or where power consumption and clocks related challenges are critical consideration. Let me discuss the some of the points of self-timed pipelined data path. First one is asynchronous operation. No global clock pulse governs to operation of the entire pipeline. Each stage operates based on local control signal independent of the others. Next one is handshake protocol. Data transfer between adjacent pipeline stages is controlled using handshaking. When the stages complete its computation, it sends a request signal to the next stage, asking it if it can accept the data. The next stage responds with an acknowledgement when it is ready to receive the data. Next one is variable stage latency. Each pipeline stage can take a varying amount of time to complete its operation depending on the nature of the data or the workload. Since there is no central clock forcing all stages to work at the same pace, each stage can process data at its own optimal speed. Next one is data flow control. Stages don't proceed until the next stage is ready, ensuring proper flow control. Next is low power consumption. Self-time pipelines can reduce power consumption by avoiding the use of a constantly running clock signal, which reduces unnecessary switching activity in idle stages. Power is consumed only when data is actively processed and transferred between stages. And another one is in comparing the original system and its pipeline version, in terms of critical path delay and maximum operating frequency, there are several key differences. Original system critical path tau 1, this is the longest path through the combinational logic of the system, determining the delay between input and output. The critical path is the time it takes for the longest sequence of operation to complete. Maximum operating frequency, that is f1 equal to 1 divided by tau 1. The maximum frequency at which the system can operate is inversely proportional to the critical path delay. A longer critical path means a lower maximum operating frequency. Pipelined version, whereas pipelined version critical path, that means tau 2 maximum frequency f2 equal to 1 divided by tau 2. In the pipelined version, the critical path is typically reduced because the operation is divided into multiple stages, with each stage handling a smaller portion of the total task. This result in a shorter critical path per stage. Whereas the maximum operating point f2 equal to 1 divided by tau 2, the maximum operating point of the pipeline version is higher because the critical path stage is shorter than the critical path of the original stage. Since each stage of the pipeline process smaller task, the clock cycle can be faster. Which means critical in critical path in the original system, the entire task is executed in one clock cycle, so the critical path is the longest. In the pipelined version, the task is broken into smaller stages, so each stage has a shorter critical path. Which means that is tau 2 less than tau 1. Tau 2 is nothing but the pipelined version, tau 1 is nothing but the critical path. Whereas the operating frequency of the original system is limited by the longest combinational logic delay. The pipeline version can be operated at a higher frequency because the critical path per stage is shorter, meaning f2 greater than f1. Okay, and what is general role of the pipeline is pipelining latches can be only be placed across feed forward cut set of the circuit. Cut set means a set of path of a circuit such that if these paths are removed, the circuit becomes a disjoint. Feed forward cut set means a cut set is called feed forward cut set if it data move in the forward direction on all the path of the cut set. Advantages of pipeline: reduction in the critical path, high throughput, increases the clock speed, reduces the power consumption at the same speed. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.